Welcome back. We're going to have an explosion of a different kind this time. There's no secrets. I've asked you to go and get some of these. So if you have your balloon, that's great. It doesn't have to be blue, but as long as you've got a sharp stick, that's fine. Now normally you wouldn't start science by introducing these two things together, would you? Quite. However, this is an interesting way to look at things because we're going to look at the materials that balloons are made of. Firstly, what are balloons made of? Well, the term that I'm going to introduce you to is one called a polymer. It just means many things. It's like a string of many things all together. Normally materials in the world are made up of any of more than 100 of the elements that make up what is the periodic table. In this case, we have latex rubber. Now latex rubber isn't just one element, it's many elements joined together, but they also join together into long strands. Think of your balloon when it's all coiled up like this as being almost like a knot of material, almost like a long clump of strands. Now when you blow the balloon up, these strands will stretch. Let's do that now. If you haven't blown up your balloon yet, blow it up and tie a knot in it. And if you can't do that, ask a grown-up to do it. Give you something to laugh at. Here's mine. That's probably big enough. Yours doesn't have to be the same size as mine. Just one you feel comfortable with. Once you have your balloon, let's examine it carefully to see where that latex rubber actually is clumped together. If you notice on the sides of the balloon that it's quite a uniform colour. However, if you look at the end, here where the knot is, and also at the other end, at the top, just there, you'll see that, well, it looks darker in colour. What that actually is where the strands haven't been pulled tight, it's where they've been allowed to clump together. This brings something important to our look at polymer science, because when they're very stretched, if you poke through those chains, you can break them. Break the chain, burst the balloon. However, when it's all clumped together, it's a lot easier to wriggle through. In this case, we're going to wriggle through this. So, after what we've just learned, the best place to poke this is going to be through where it's the darkest colour. So probably at the end here. Now hold it far enough away from you because, as you've just seen, balloons do burst. So let's start by squirming it around and poking it in a little bit at a time. It should, if you apply enough force, go through quite quickly. Well, that's a joy. I've already got it through one end. That's fantastic. That's only part of the trick though, isn't it? Because the next part is to get it through the very end, where you can see that it's also a dark colour. That's where those chains are all still clumped together. So let's do that. Carefully find where that is. And when you've found it, just try to weasel it through a little bit more. Let's see whether we can get a whole balloon on a skewer. Oh, well, that's a joy. I now have a whole balloon on a skewer. It goes from that end all the way to that end, and it hasn't burst. So that teaches us a lot about the science of what these things are actually made of. But there's another way of looking at this. What I have are two balloons. So what you'll see is that one clearly is much, much bigger than the other one. And they're joined by this hose in the middle, which means that when I remove that clip, then the air should be shared between the two of them. So what's going to happen to the two balloons? Are some of you thinking that it might be the same size? That the air from this one, because there's more air in it, will rush to this end? Well, let's have a look. Let's have a go at this experiment. Are we ready? 3, 2, 1. Oh, so that's interesting. The air at this end already had a lot of air in it, and now it's got even more in it. And actually, this is all due to the balloon itself. The S, what we might describe as the air pressure, is indeed the same in all of the system now. But think about this another way. When you blow a balloon up, which is the hardest part? Isn't it right at the beginning? It's teeny. Isn't it at the beginning when all those coils are all jumbled up together and you have to start to untangle them to get them to stretch? Once those polymer chains start to stretch, well, they find it really easy, but they don't like being woken up. So there we have a little science about polymers. Now, what I'd like you to do is go into your kitchen and I want you to investigate polymers. And that sounds strange, but I want you to pick out objects and foods and things like that that you think contain polymers. They might look like balloons. They probably won't taste like balloons. However, while you're in the kitchen and in preparation for the next experiment, I also want you to get a few other objects. So I'd like you to get a plastic cup, a couple of drawing pins, just plain metal drawing pins, some bicarbonate of soda. You might find it's called baking powder. I'd like you to get a 9-volt battery. Yes, the same one that we used in the Bernie episode. And also, if you have access to a hot glue gun, then that would be useful too. Not essential, but if you have one, just be careful with it. If you don't have one, then a little bit of blue tack might be useful, or even some chewing gum provided you've chewed it first. Right, we'll be back here for the next episode where we are going to make some hydrogen gas. I know. So you want to be here for that one. So in the meantime, that's all from me, and I will see you soon. Bye.